Hello everyone. Today is the 74th day of Leetcode 75 challenge. Let's begin with the 74th question. Question 739, daily temperatures. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the easiest way possible. You are given an array of integers temperatures where temperatures I represents the temperature of the ith day. So basically an array is given, okay, and each index each index represents the temperature on that particular day. Okay. For each day, you want to know how many days you would have to wait until a warm up temperature occurs in the future. That means that if today is 72 degree Fahrenheit, suppose, or Celsius would be a lot, then when will be a warmer temperature? After how many days? Suppose next is 69, then it's 58, suppose, and then it is suppose 98, right? So we can see after 3 days we can get a warmer temperature than 72. So this is what is depicted in the second line. So this is what they want to know. So if no such future day exists, the number of days to wait for the day is zero. Suppose after 72 there is no 98. Okay, the temperature is declining. Then suppose after 58, suppose there is even 68 is there or 40 is there. The next day for this will be zero because no other day is present in the array which represents a temperature more than 72. Okay. So your task is to return an array of answers of the same length as temperature, where answer of I represents the number of days you must wait after day I to encounter a warmer temperature. The result is an array of integers of the same length as temperature. So in a nutshell, they are trying to say that if we have to suppose these are the temperatures given to us uh, this way, okay. So we have to return the exact array of the same length, and each ith index of the array will depict that how many days from the particular day we have to wait to get a warmer temperature. If we can see here 72, so we get the warmer temperature is 72 at the last. So after 3 days, right? So here it will be 3. Got it? For 68 it will be 1 because after 68 after one day only we got the higher temperature. So this is what they want. And if there is no temperature after 82 there is no, so it will be 0, right? So this is what they're trying to say, and they need as the output. The constraints of the problems are the temperature's length is from 1 to 10 to the power 5, and the temperature's ith value will be from 30 to 100. So I hope you understood the problem explanation and the constraints. So now let's move to the next slide. Now let's understand the input output explanation. Let's take this example here: 30, 40, 50, then it's 60, right? So we have to return the exact same array length. So after 30, which is the maximum temperature, or the higher temperature just after 30, it is 40, right? So it took only one day to get a higher temperature. For 40, it's 50. It took only one day to get a higher temperature. For 50, it's 60, right? So it took only one day. For 60, there is no more temperature, right? So the output will be 0. Got it? I hope you got this example. Let's take this example: 30, 60, and 90. Okay. From 30 to get a next higher temperature, it's 60 after one day itself, right? For 60 also it's 1, and for 90 it will be 0 because there are no more temperature given to us after 90. Okay. So I hope you understood the input output explanation. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Let's do it by understanding the goal. Okay. So you are given a list of daily temperatures I, where ith day is a date index. For each day, we want to know how many days to wait until a warmer temperature occurs. Okay. If there is no future day with a warmer temperature, the answer is 0 for that particular day. So our goal is to construct an array of answer that where answer of I is the number of days to wait for a warmer temperature. Okay. So we have the proper understanding of this, what it particularly trying to demand. So what could be the brute force solution? A brute force solution would be, suppose if this is the array and you have some temperature x, x1, x2, x3, x4, right? So what we can do, you take this, suppose you took x0, right? Then you iterate this complete leftover array looking for the ith day which has a temperature greater than the x0. Again, we will come back for x1. We'll iterate from x2 to x2 to xn, checking for any temperature which is greater than x1, right? So it will take O of n time complexity to iterate by taking each day one by one, n into O of n, because for each ith ray you will iterate the leftover array, right? So therefore the time complexity would be O of n square, and this will be an inefficient solution for this approach. So we have to look for a much more efficient solution. Okay, let's look into it. So let's try to visualize the process now. So before going for the intuition, let's understand something. Understand something about monotonic monotonic stack. Okay, so there are four kinds of monotonic stacks. One is increasing stack, basically next greater element. Then there is decreasing stack, which is basically next smaller element. Then there is increasing stack, which is basically previous smaller element. Then there is again decreasing stack, which means previous greater element. Okay, so these are four kinds of monotonic stack. Either the stack would be increasing or the stack would be increasing. The values in the stack, either it will be in increasing format or it will be in decreasing format, and those are of four types. One is a stack will be increasing if the next looking for the next greater element. So every time we store the next greater element into the stack. A stack would be decreasing if we try to store the next smallest element into the stack. Okay, and there would be next there would be greater increasing stack again, by which if we store the previously decreasing element. Okay, next decreasing stack will be there, which will be storing previously increasing element. Okay, these are the four types of stack, and in this case and in this particular problem we will be using the increasing stack. Okay, which is basically next greater element. So we will be using this particular monotonic stack in our question. Okay, so I hope you got the idea about monotonic stack. Okay, and we are using increasing stack, which is basically next greater element. Fine. So let's take one example here. Fine. So first thing, this is the example, and why we are using monotonic stack here, or we could say a stack problem, right? Why it is a stack problem? First thing, the stack stores indices, right, of the days whose next former day hasn't been founded yet. Fine. As we iterate backward or forward, we can quickly check the top of the stack to see if the current day resolves our waiting days or not. Okay. And third, popping from stack ensures that each day is processed exactly once, making it efficient. So these are the few reasons why we are looking for the stack here. And also, if and as we go through the intuition part, you will have a gradually will get the idea about why this is a monotonic stack problem. Fine. Now let's take a stack here. Okay, and let this be the array for our answer. Fine, and let's start from here. 73. So since it is, so we'll place 73 here of the index. Let me write the index also: 0, 1, 2, 3, 4, 5, 6, and 7, right? So it's index 7. Then we will come to this index 76. Is 76 greater than 73? It is, right? So what we will do? We know that, and also let's fill this with 0. How many have we done? 3, 3, 6, 7. Fine. So what we will do? What I will do? I will just pop this 73. Okay, this 73 has been popped. So from here we'll come here now, and we will put 76 here. Okay, the index is 6. Great. No. Please be with me here. Okay, now it's 72, right? Is 72 greater than 76? Or we can write it's 72 less than 76 or equals to 76. Yes, it is, right? So for 72, we will place 72 here with index 5. And what is the difference between those? It's 1, right? So what we will do here, we will write 1, or I will just remove this and I will write 1. Till now, if you have observed, it was 73, already 0. Already 0. Why already 0? Because after 73, we cannot see any temperature, right? So for this, the answer would be always 0. Given any array for the nth minus 1 index, the answer would be always 0 because we don't know the next temperature given to us, right? So that is 0. After that, when we try to push this 76, we saw that, yeah, 76 is greater than 73, right? And there were no more values greater than 76 in the stack. So again, it will be 0, right? Because no greater temperature is present after 76. Now, when we came to 72, what we did, we checked. We saw that 72 is smaller than 76, right? So definitely we found our one of the solution, and the distance between them is 1, right? So that is why it's 1 here. Great. Now we come to 69. We see the 69, is it smaller than and greater than greater to the stack dot top, or 72 right now? It is 2, right? And the difference between them is how much? 1. So what I will do, I will just put it here, write the index, update this to 1. Fine. Great. Again we come to the 71. Nice. So when we come to 71, we check the same thing. Is 71 less than or equals to the stack dot top, which is 69? It's not, right? It is greater than 69, which means that it cannot, it is not a warmer temperature. 69 is not a warmer temperature. So what we will do, we will just pop it. We popped it. Fine. Again we will do stack dot top. We get 72. Yeah, so we can see that 72 is greater than 71, right? So what we will do, we will place 71 here with the index 3. The difference between 3 and 5, or this two index, is 2, right? So here we will get 2. And also, if you can observe the stack, it's a increasing stack, right? From up top to bottom, we are having 71, 72, 76, right? 73 is not there. So 71, 72, 76, all are in increasing format. Fine. Now let's move ahead. Now we are standing at 75. Let's forget about this. Now 75. Is this greater, smaller than or equals to stack dot top, which is 71? It's not, right? Because 75 is a greater temperature than 71. So we need a temperature which is greater than 75, right? And so what we will do, we will pop this. Done. We will check with 72 now. 72 is also smaller than 75, right? So we will pop 72 also. Then we will be having 76, 75 compared with 76. So this condition is true, right? Let me clear this up now. So what will happen? I will add 75 here with the index 2, right? The difference between the 75 and the 76 is how much? It's 6 minus 2, it's 4, right? So here, instead of 0, it will be 4. Fine. Great. Let's move back. Now it's 74, right? Is 74 less than or equals to 75 or the stack dot top? It is, right? So the difference between those is 1, right? If you can check the indexes from the stack also. So what I will do, I will place 74 here, the index 1, and this will be index 1, right? Again, I will move to 73. Is 73 less than or equals to stack dot top, which is 74? It is, right? And the difference between them is also 1. So instead of 0, it will be 1, right? So our final array comes out to be 1, comma 1, comma 4, comma 2, comma 1, comma 1, comma 0, comma 0, right? Now if you check it from here, 73, the next greater temperature is 74, right? So if you can see, the next greater temperature for 73 is 74, so it will be 1, correct? For 74, 75 is the next greater, so distance is 1. For 75, the next greater, if you can see, it's 76, the distance is 4. For 71, next greater is 72, distance is 2. For 69, it's 72, right? 1. For 72, it's 76. And for 76, we don't have anything, right? So it will be 0. For 73 also, we don't have anything, so it will be 0. So if you match this with our output, it's matching, right? And also, the array or the stack is in increasing order. 74, then 75, then 76, right? So I hope you got this intuition, how it's running and how the problem is going ahead, right? Because if you're coming from the back, it makes much more sense, because for 73 we don't have anything in a forward direction, right? So it will be definitely 0. And when we go back, we keep on popping until and unless we get a value. Suppose in this case of 71 and 74, we kept on popping until and unless we got a value which is greater than 75 or 71, right? And instead of storing these values, in actual we will be storing the indexes. Fine. So if you see here, we iterate from left to right using a monotonic stack that stores future indices with the warmer temperatures. Okay. For each day, starting from the last, while the stack is not empty, the top of the stack is not warmer, we pop it because the future day is not helpful anymore. Basically, the temperature which we have in the stack is lesser than the temperature which we have in the outside. After popping the colder days, if the stack still has an index, it means we have found the nearest warmer future day. So we update the answer by taking the difference. And finally, we push that particular temperature in it. And why stack? It helps efficiently track only useful future warmer days, avoiding repeated searches. In whichever kind of a question, if you see that you have to predict something of the future and you need it only for once, right? And instead of, if you can see the time complexity is O of n square and it can be converted to O of n, please go for stack. Right? This is the example which we took. Now let's see how we can simulate this. We can initialize the stack and answer array with 0, default zeros all day, right? Definitely, because for the last indexes we don't have anything, so it will be 0. Iterate through the temperature with index from last to first while stack is not empty, and current temperature, if it is greater than or equals to the temperature in the stack dot top, we will pop it. Otherwise if we don't pop it, what we will do, and in answer of I we will store the differences. If this is false, we store the differences, and if it is true, we pop it. Okay. And if neither is, if the stack is itself is empty, we will just push the value into the stack and move ahead. Okay, these are the three scenarios that will happen, and at the end we will return the answer. Okay, so I hope you understood the intuition. It was pretty easy and straightforward. You just have to know about the monotonic stack and where to use the stack. So what to figure out? Figure out that the stack ensures you can quickly find the next warmer day in the future for each day without checking all the latest day individually, right? Because if we have store, suppose, let's make it much more clear. Suppose if we have some values this way, just random values are there, okay? And if you have uh, already stored these values, we're coming from the back, right? And when you're standing here and you have to know, tell me where is a value greater than 2, which is basically greater than 3 times greater than 2. So it is 6, right? 2 into 3, 6. So we are looking for 6. So, and if in the stack we already have this value stored with us, and that value will be used only one time for this particular 2, right? So what you will do, you will this pop this value, pop this value, and pop this value, and you have 1 again, 6 here, right? Great. Again in 1 you are standing and it is said that find me a value which is 6 times greater than this particular value. So we already have it in the stack, and these all values are useless for us now. Something like that. It's a layman term to explain you this particular thing, but yeah, I hope you're getting this idea. In this kind of scenarios, using a stack is much more beneficial than iterating it multiple times and getting a O of n square time complexity. Each temperature is pushed and popped at the most efficient O of n time. The approach guarantees that number of days to wait is correctly computed for all days. So I hope you understood the intuition explanation. Now let's move to the next slide. Now since we got the intuition of the problem, let's look into the approach how we're gonna solve it. Step 1. Initialize the tracking. Create a stack to track indices of days waiting for warmer temperature. And one more thing, in Python we don't have inbuilt directly stack used. So what we do, we use list as a stack by popping it from the back. Fine. So we initialize a stack n for the temperature's length, an answer of 0 into multiplied by n, because the output array will be of same as the temperature's length, first thing, that is why n. And why multiplied by 0? Because there might be a case the value which is given to us in decreasing order. Suppose 7, 6, 5, 4, 3, 2, 1, right? So in that case, all of those value outputs will be 0. So just preparing it for initially. Step 2. Single pass through temperatures. We iterate through each day in the temperatures array for I in range. It's not basically I in range, it's basically for I in range n minus 1 minus 1 minus 1. Basically, starting from the end, stepped once and stop at minus 1, right? Before minus 1, basically. This is the steps. Step means jumping one time, and minus 1 means before minus 1, stop at 0. This is what it means. Okay, so we pop the values on the stack if the current value is greater than the given value. Otherwise, we take out the difference and we append it to the stack. Fine. Step 3 is the final result. We return the answer array containing the number of days for weight of the warmer temperature. Return answer. This array gives the correct waiting period for all the days with 0 where no warmer days exist. Okay. So I hope you understood approach explanation. It was pretty short and straightforward because there was nothing too much to worry about, right? So let's move to the next slide now. The code is the exact copy of the approach discussed. Let's understand it line by line. If you can see here, we have already taken the length of the temperatures, initialized the answer array and the stack. For the range, this is starting from n minus 1. So this means start. This means when to stop. This means how many to skip or step. Fine. Minus 1 means jumping each step. Minus 2 means jumping 2 steps at a one from the last, right? And minus 1 means stop at minus 1. Means at 0 is the last checking point. Okay. And now, if you can see here, when the condition is true, we pop it. Otherwise, the condition is false. We push it into the stack, right? Basically, not false, you can say, because there might be a condition that you keep on popping, right? And stack becomes empty. If stack becomes empty, this condition is not true, right? So you come here and you just push it into the stack. And second scenario, if you keep on pushing, and suppose you were having 74 and keep on pushing and you got 78 after four times popping out a particular value, right? And you have still one value in the stack. So if stack is not empty, then we check the difference of both of them, right, and store it in the answer, and then later we push it into the stack. Okay, and at the end we return the answer. So the time complexity for this is O of n, and space complexity is also O of n. Now you might be wondering that why the time complexity is O of n and why it is not O of n square, even though we are having one for loop and one while loop, right? It should be O of n square technically, right? So why it is not O of n square but it is O of n? Reason being, even though there is a nested while loop, each index is pushed and popped from the stack at most once, which means total operation across the whole loop is linear. What it's trying to say is that suppose this is the stack, right? In for loop, just forget about the while loop, right? But popping the values, keep on popping the values 1, 2, 3, 4, right? Then 5. And still the range is there, right? The for loop is not done. Then you come to the while loop for some condition, right? And you pop these values, taking time complexity O of 1. Okay, O of 1, O of 1, right? You popped 4 values. Did we came now suppose the range was 1, 2, 3, 4, 5, 6, 7. Let me clear this up. 8, 9, 10, 11, 12, right? And you entered till 5, right? So you are standing here in for loop condition. And in the while loop, you replaced this, you just basically popped all these values, right? We did it. Did we came back again from the for loop? No, right? We're still standing here. Did the while loop iterated from the top till 6? No. It just popped the values from the stack. Now, when I will move ahead, I will just place 6, 7, 8, 9, right? And I will stand at 10. Again, what will happen? While loop will pop these values, right? Isn't it going this way? No, right? It is not coming to this loop again, right? It's just popping the values which are already in the stack. And at most, we can see one has not been popped till now, right? So at most, the condition could be one time pop, one time push. At most. At most, this could be the scenario, right? That is why, since we are not doing multiple iterations, we're just popping the values which are already present into the stack and which have already been iterated, and we are not iterating that values again, right? We are just stopped at here and we're just popping the values. That is why the time complexity is O of n, not O of n square. Okay. And also, if you want to see understanding another way, suppose pushing takes O of n total time complexity from the for loop, popping takes O of n time complexity, right? If we add it, it's 2n, right? O of 2n, which is basically O of n. So I hope you're getting the idea why the time complexity is O of n and space complexity is O of n, because we created a stack which size could might go up to O of n in worst case scenario, and also an answer array which is already of O of n size, right? So I hope you understood the code explanation along with the time and space complexity. So now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. So let's take this example already. It's 73, and also I have brought down the code here for our better understanding. Okay, let's begin. Let me also create the. So let's begin, right? So we have the stack here. We have the answer array with us initialized with 0, right? Let's begin. We are starting from the last index, right? Let's check here. We're checking if temperatures of I, stack of I is already empty, right? While stack, so it's already empty. So we'll skip this part. Again, the stack is empty, so we'll just put the seventh value here. That's it, and we will move back. So this will also come here. Fine. Again, we will check. Stack is empty. No, it's not empty. Temperatures of stack of I minus 1. So basically this one, right? Last index value of the stack. Is it less than or equals to the temperatures I, right? Which is 6th index. So it is 76. And this is 73, right? So it's true, right? Since it is true, what I will do, I will just pop it. So this will just get popped. And from here, we move here. And if the stack is, now the stack became empty, right? So we will append this 76 or this 6th index here. Great. So this is done. We will come back here. Stack is empty. No, it's not empty, right? Temperature of the last stack, which is 76. Is it less than or equals to 72? No, right? Stack of I minus 1 means this value, and temperatures of I 72. It's not, right? So this condition is not true. So what we will do, we'll come to this condition. Is stack empty? It's not empty, right? So if it is not empty, what we will do, we'll just subtract the indexes. So it's 6 minus 5, it's 1, right? It's 1. So here we will write 1 answer of I, right? And after that, we will append this to our stack. Great. And we will move back. Again, it's 69. Same scenario. Same scenario. If you can see that. Again, it's 69. Is 69 less than or equals to what's the value? 72. No, right? Simply, we will just take the difference because we have values in the stack, right? So the difference will be 1 again, and we will store this into the stack, which is index 4. Let me clear this up. Nice. Now, so we are standing at 73 now, 71, right? So what we'll do is 69 less than or equals to 71. Yeah, it is, right? So what we will do, we will pop this value. Done. Again, we will come back. We will check index 5. What is the index 5 value? It was 72, right? So it's now condition becomes false, right? So what we do here, we come here, we do the difference. So we were standing at 3. So 3 minus so 5 minus 3 is 2, right? So this gets updated to 2. This gets removed, popped. Let me get this up, right? And then we come here, we append this 3 into our stack, and then we move ahead. Fine. Now, so we can see that it's 75 now. Is 75 not 75? And the stack we have 71, right? So we can clearly see that 71 is less than 75, right? So what we do, we just pop this. Done. So it's fifth index value. Fifth index value is 72, right? Again, 72 is less than 75. So we pop this also. Now, sixth index value is 76, right? So 76 is of course not smaller than 75, right? So what we will do? This will get popped, right? This is done. and difference between this 6 and we were standing at 2, right? So 6 minus 2 gives me 4. So I will just store 4 here and the second index, and we will move back. Now we'll check again, coming back to this. 75 is not less than or equals to 74, right? That means it is a greater temperature, so we won't be popping anything. We will just take the difference, which is 2 minus 1, it's 1, and we will store the one index here, and we will move back. Right, this is done. Now we will pop the thing again. We will check. Okay, 74, it is less than 73. No, so nothing is done here. Stack is not empty. We check the difference. 1 minus 0 gives me 0, gives me 1, right? So we will store 1 here in answer. We will append this 0th index here, right? And we move ahead. After that, the iteration is complete, right? And we can see our array. It is 11421100. So it is 11421100. So we got the required output, right? If you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, the approach, the code. After that, do a dry run by yourself on 2 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. So now let's move to the next slide. Now, since we are familiar with the problem and the solution, let's move to the lead code and code the solution. So let's start coding. First, let's take the length of the temperatures, right? And answer equals to 0 into n. I hope you're getting it what we are trying to do here. We're using the stack here for in range, starting from the last index, stopping at -1, stepping by 1, right? While stack is not empty and the temperature stack, when we do this, right, we're taking the index from the stack, right? Suppose index 3. So if you're getting index 3, so that index 3 value in temperatures is what? So that is what is happening here. If you are not getting that till now, if that thing is less than the temperature current value, that means it is a colder temperature and we have to pop it. Okay, and after that, if the stack is not empty, right, and the popping is done, no more thing is to be done, right? So what we do, we take the difference, stack of I, not I, sorry, -1 minus by I. Okay, and after that, what we do, we stack dot append the value or the index. After that, let's return the answer. Let's try submitting for the sample test cases. Now let's finally submit our solution. So we have successfully submitted our solution. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.